Welcome to our super quick overview of acid nomenclature. Remember that acids are compounds formed of hydrogen and then some other non-metal element. We're going to dissolve these guys in water to make them acids. Our objectives for today, we're going to review how to recognize and name binary acids. Binary means two. We're going to review how to recognize and name oxyacids. These guys are sometimes also called ternary acids. They all have oxygen in their formulae. Just a quick little look at what acids are. In the spring, we'll have a unit where we talk about these guys a lot. For now, just go with acids are compounds formed when we have hydrogen bound to some other non-metal. Super cool thing happens when we dissolve these guys in water. Let's say that this is HCl, hydrogen chloride. We have a hydrogen atom, we have a chlorine atom. They're sharing electrons, but when they dissolve in water, they pop apart, they dissociate or pop apart, the hydrogen and the chlorine. But the chlorine is going to keep hydrogen's electron, so it'll stay chloride, and then that hydrogen will lose its electron, so now it's a positively charged cation. And because hydrogen is basically just a proton and an electron, you take its electron away, all that's left is a proton. Sometimes we call these guys protons instead of hydrogen ions, but they're totally the same things. So in the water, we would have hydrogen ion, negatively charged anion, hydrogen ion, anion, hydrogen ion, anion. And this dissociation, these separate charges floating around in the water, is what gives acids their properties. One of the most famous, of course, is that acids are pretty corrosive. The rest of today's lecture is about naming acids, and we actually have two different groups of rules to name acids, and so we need to be able to categorize the acids so that we know which group of rules to use. So acids can be binary or they can be oxyacids. Binary acids, bi means two. Binary acids have two elements, only two, no more. The first element is always going to be hydrogen. The second one will be some other non-metal. Two elements, hydrogen and one other. Examples are HCl, hydrogen and chlorine, hydrogen and sulfur, hydrogen and iodine. Notice hydrogen and one other element, total of only two elements. Oxyacids, also called ternary acids, are going to have more than two elements. Basically, they're going to be hydrogen and then one of our polyatomic ions. If you don't already have your list of polyatomic ions handy, I suggest you grab it. These are all oxyacids, also called ternary acids. Notice we have hydrogen and then two more elements, 1, 2, 3 total. One of those elements is oxygen. ClO3 is one of our polyatomic ions. SO4 is one of our polyatomic ions. IO2 is a polyatomic ion. It's not on our list, but we're going to talk about what it is. Notice that we don't always have the same number of hydrogens, though. Sometimes there's two, and sometimes we have an invisible one. Talk real quick about why that is. I'm going to erase some of my scribbles here so that we can see those subscripts a little bit better. So chloride has a charge of -1. I need one hydrogen with a +1 charge to balance out that chloride. Sulfur's oxidation number is -2. Hydrogen is still just a +1. I need two hydrogens, +1 to balance out the -2. You might be thinking to yourself, wait, Lentz, hydrogen is a nonmetal. We shouldn't be balancing charges. I know, right? But we do. For hydrogen and a nonmetal, when we're talking about acids, we do actually balance the charges. Weird, right? Crazy sauce. But that's what happens. Iodine is a -1. Hydrogen is a +1. 1 and 1 is going to balance out to a 0, so I only need one hydrogen for that one iodine. Same thing for our polyatomic ions. This is chlorate. Chlorate's charge is -1. I only need one hydrogen to balance out those charges. Sulfate, however, is a -2 charge. I need two hydrogens to balance out that -2 charge on the sulfate. This is iodite. It has a -1 charge, hence only one hydrogen necessary. We're going to look at naming binary acids first here. So binary acids, remember we only have two elements, hydrogen and something else. The rule is hydro something else ic acid, hydro something ic acid. We're going to put hydro before the second element's name. We're going to change the end of the second element to ic acid. So if I have HCl, I'm going to put hydro in front. I only have two elements, hydrogen and chlorine. We're always going to start with hydro. Hydro, I'm going to turn chlorine into chloric acid. hydrochloric acid. 2 elements, hydrogen and fluorine. It's binary because there's only 2 elements, hydrogen and one other. We're going to always start with hydro. Fluorine will become fluoric acid. H2S, I have 2 H's because sulfur's charge is -2, but I'm still just going to call it hydro. Sulf becomes sulfuric acid. And one more, H3P, phosphorus is a -3 charge, so I need 3 hydrogens to balance out. 1 positive 1 times 3 is going to balance out that -3. I still use hydro because I still only have 2 elements. I have 3 copies of hydrogen, but I still only have hydrogen and phosphorus. Hydrophosphoric acid. Good. Hydro something ic acid if our acid is binary. But what if we have an oxy acid or ternary acid, not binary? Instead of only 1, 2 elements, now I have 1, 2, 3 elements in our acid. What we're going to do is we're going to figure out the name of the polyatomic ion, because the reason that we have more than 2 elements is because we have hydrogen and a polyatomic ion. If you don't have your list of polyatomic ions handy, I highly recommend that you grab it right now. Hydrogen and a polyatomic ion. We're going to figure out what the name of that polyatomic ion is. It's either going to end in ate or it's going to end in ite. You might have nitrate, you might have nitrite. It's going to end in one of those. If our polyatomic ion ends in ate, then we're going to change the end of it to ic acid. If the polyatomic ion, though, ends in ite, we're going to change the name of the polyatomic ion's end to us and then acid. So here, HClO3. Let me pull up our list of polyatomic ions super quick. Here, again, we have ClO3. ClO3 I find on my list of polyatomic ions. It's called chlorate. If it ends in ate, we're going to change it to ic acid. No hydro, so not hydrochloric acid, but just chlorate turns into ic acid, chloric acid. Notice no hydro. How about ClO2? ClO2 is right under it. That's chlorite. Chlorite. Ite will turn into us acid, chlorus acid. This is chloric acid, this is chlorus acid. Remember that on the previous slide we had HCl? It was binary. It was called hydrochloric acid. But in our polyatomic ion list, there's never a hydro. No hydro here. How about H2SO4? We're going to find SO4. SO4 is here. Its name is sulfate. 8 turns into ic, my friend, so we're going to call this sulfuric acid because sulfate turns into ic acid. Sulfate, sulfuric acid. SO3 is right under it. SO3 is sulfite. Ite turns into us. So this is going to become not sulfite, but sulfurous acid because ite turns into us. H turns into ic, and ite turns into us. Let's practice a little bit. So I highly recommend that you pause the video, do these on your own, and then restart the video and check your work. Hopefully you're ready to check your work. I have 1, 2 elements here, so it is a binary acid. We're going to use hydro something ic acid. It's going to be hydro, bromine becomes bromic, hydrobromic acid. This guy, we're actually going to skip him. He's kind of weird. He shouldn't be on our list. HF. HF is going to be hydro. It's again binary. Fluorine turns into fluoric acid. H2SO4. SO4 is a polyatomic ion. It is sulfate. So I'm going to turn 8 into ic, and we're going to get sulfuric acid. SO3. SO3 is sulfite. We don't actually keep those in the names. I'm just putting them there to help us remember that ite turns into us. So sulfite will become sulfurous acid. Also, you're like, why do I know to add the back in there? We just do. There's not really a rule. Sometimes it just sounds better to throw those back in there. If you were to write on a quiz sulfuric acid on this one, I would not be mad. I'd be like, you know the rule, it's okay. But this is better. But this would be, I don't know, it would get you credit. All right, let's do two more. PO4. PO4 is phosphate. So I'm going to change 8 to ic. We have phosphoric acid. Phosphoric acid because H turns into ic. One more. CO3. CO3 is carbonate. One more time. H turns into ic. We have carbonic acid. Carbonic acid. Good. All right, my friends. Well done today. We accomplished our objectives. We reviewed how to recognize and name binary acids. Binary means 2, H, and then some non-metal. We're going to use hydro something ic acid. We reviewed how to recognize and name oxyacids or ternary acids. There's more than 2 elements, hydrogen and a polyatomic ion. We have no hydro, remember no hydro. Instead, we're going to turn H into ic acid, and we're going to turn ite into us acid. Remember that acids will always start with hydrogen in the compound, but we're going to start with hydro in the name only if it's binary. Good work today.